Well, hello 2D, and welcome to the first video of Unit 1. We're going to take a look at a review of skills today, and specifically the skills involved in finding what angles are equal in geometric situations. So I'm going to review a few theorems and tell you when you might get to see them. So the first theorem that we're looking at here is called the opposite angle theorem, and we abbreviate that to OAT. Anytime you tell me that two angles are equal, and they're equal because of the opposite angle theorem, you should put in brackets and then OAT beside it to let me know which theorem tells you that you can say that. So what does the opposite angle theorem say exactly? When two straight lines cross, opposite angles are equal. And so in this diagram, I've shown you that the opposite angles, they're marked with X's here, so those two have the same angle value, and these two have the same angle value. And we can get a little bit more information from this. Whenever you have two straight lines cross, you're always going to have an acute angle, which means less than 90 degrees, and then one beside it that is greater than 90 degrees, which we call obtuse. And that will happen unless they meet at 90-degree angles. And if that's the case, then all four angles are going to be 90 degrees. Now, moving along, we have the angle sum of a triangle theorem, or ASTT. The angle sum of a triangle theorem tells you that all of the angles within a triangle add up to 180 degrees. So we have x plus y plus z equals 180. Now, this gives you a way of finding a third angle. If you know two angles, then you can just subtract their total off of 180 degrees to find the third one. The next one is the exterior angle theorem, or EAT, E-A-T. This says that any exterior angle of a triangle is equal to the sum of the opposite interior angles. So what does that mean? Well, an exterior angle occurs if you extend the side of the triangle. So we extend this side, and then this angle outside is exterior. And so it will equal this and this added together. Now, the reason that that happens is because both this straight line here and the three angles in the triangle have to add to 180 degrees. So if these two things add to 180 and these three things add to 180, then this piece here and these two pieces here must equal the same thing. Okay? So the way we would write that down, we would say x equals y plus z. Now when I extend a side of a triangle, so I could extend here, I'll use a different color, I could extend this side out. This here would be my exterior angle, and now it would equal the same as this angle and this angle put together. Okay, and we could do the third way over here. Let's pick a different color. Let's go with green. This angle here would be the same as this one and this one put together. Carrying on. Now we're going to talk about the parallel lines theorem. So there's three different parallel lines theorem. Whenever you have parallel lines, and that's what these little marks here mean, it means that these two lines are parallel. If it's cut by a transversal, and a transversal is just a line that cuts across other lines, okay, it says corresponding angles are equal. So what are corresponding angles? Well, corresponding angles are ones that are in the same position in each intersection. So this one corresponds with this one. This one corresponds with this one. This one would correspond with this one. And lastly, this one would correspond with this one. Okay. Now we call this PLTF because you can see if I take my blue pen and I'm going to mark the blue angles that I have here, you can see that if I mark those two blue angles, they roughly make an F pattern. And it doesn't matter whether it's frontwards or backwards or upside down, so let's do it with the red ones. I'm going to mark out the red angle. There's one red angle. Here's the other red angle. So now we have an upside down F. Okay. But basically they just correspond to the same location in each intersection. Okay, the next one says alternate angles are equal, and we call that PLTZ. So alternate angles being equal. What are alternate angles? Well, alternate angles lie on opposite sides of this transversal and they're inside it. So this and this would be considered alternate angles. And this would be considered alternate angles. Now, the reason why it's called PLTZ is because if I take my green pen and I highlight those two angles. So there's one green angle, and the other green angle here would be made by these two lines. Well, it looks like a Z. And if we use a different color for the other ones, it kind of looks like a Z too, but it could be backwards or stretched or things like that. But that's what alternate angles are, and we abbreviate that to PLTZ. Now the next one says interior angles have a sum of 180 degrees. So what does it mean by interior angles? Well, it's kind of like the alternate angles, except they have to be on the same side of the transversal. So to be an interior angle, it has to be this one, and I'm going to use a different color here because these two angles are not the same. You can see that. This one is acute, and this one is obtuse. So when I was using the same color, I was using it because the angles were exactly the same size. Well, in this case, the angles aren't the same size. One is very small and the other is very large, but they do add to 180 degrees. So those two things in here have a sum of 180 degrees. And we could mark them as x and y if you want and say x plus y equals 180 degrees. Now the same thing occurs on the other side. Let's do two different colors here. This one and this one also will have a sum of 180 degrees. Yellow's maybe not the best color. Now, the supplementary angle theorem, I already sort of alluded to this when we were talking about the exterior angle theorem. Anytime you have a straight line, anything coming off of it, any angles that make up this straight line are going to add to 180 degrees. So in this case, we have x, let's not use the yellow anymore, x plus y equals 180 degrees. Now this actually will also be the case if we have more than one. So say I have a straight line and I have three things branching off of it, and we're going to call that x, y, and z. Well, in this case, x plus y plus z will also equal 180 degrees. Okay, so that's our review of geometry. Just remember that if I ask you something, if you use, say I gave you two lines, this is just a really quick example, and I said that this one was 25 degrees, and I asked you to find me some other lines. So say you wanted to find this line here, and you know that that makes up 180 degrees. So you would find this one by doing 180 subtract 25 to get your answer. And then once you get your answer, you have to give me a reason why you did this subtraction. And the reason you did that subtraction is the supplementary angle theorem. So just in brackets, you're going to write SAT for supplementary angle theorem. Or if I wanted you to find this angle down here, you could tell me that that one was also 25 degrees. And that is because of the PLT, and this is, if you look at it, it's the F pattern. So the PLT F pattern. Or you could tell me that it's corresponding angles, not alternate. Corresponding angles, or just something along those lines. Okay, now going on, another review we're going to have is just solving proportions. And there's three different ways that you can solve proportions. And I'm going to go through all three of them. You do not have to do all three of them, but sometimes it's faster to do one way than another. So it's good to know all of them. But if you do it by the same way every time, you should be good. So taking a look here, I'm going to solve the same thing three different ways. The first way is by comparison, which means that we're going to find the multiplication factor from one ratio to the other. So if I take a look at this, I can see this very plainly that to get from 6 to 18, I have to multiply by 3. And if you don't know what the multiplication is going from one to the other, you could have just done 18 divided by 6 to get 3. That's where this comes from. And so since I had to do 6 times 6 times 3 on the top, I also have to use that same factor on the bottom. The only thing is I have to change 27 into x, and it's going back the other direction. So going from 6 to 18, I multiplied by 3. Going from 27 to x means I must have to divide by 3. So in this case, x is going to equal 27 divided by 3, which is 9. Now you can do that, but if this number is not nice, that times by 3 is not nice, then it's not a very nice question to do. So solving by isolation is an easier way to do it. So there's 3 steps involved in solving by isolation. It says you need the variable on the top of the ratio. If it's not already on the top, you need to flip it. So in this case, the variable is not on the top. So we're going to flip it. So we put x on the top and 6 on the bottom. But if we flip this ratio, we've got to flip this one too. So we get 27 on the top and 18 on the bottom. Now we have to multiply both sides by the denominator of the x. So whatever is underneath your variable, you're going to multiply both sides so that that gets your x completely by itself. But then you have to multiply this side by that as well. So what you end up getting is x equals 27 times 6, because that's what this is, like 6 over 1, so you have to multiply the tops, multiply the bottoms, divided by 18 times 1, which is just 18. And if you type that into your calculator, you're going to get 9. Exactly the same answer. This way was a little bit easier, but this way works every time if your numbers aren't nice. And one more, and I like this one a little bit better. This is cross multiplication, and your numerator does not have to, or your variable doesn't have to be in the numerator to be able to do this. So here's what cross multiplication says. And I'm going to give you just a little introduction here of why we can use it first. I'm going to show you a pair of equal ratios. So let's say 2/4, and that will be the same as 4/8. Now I hope everybody can see that 2/4 and 4/8 are exactly the same thing. But let's see what happens when we actually multiply crossways. We're going to multiply numerator by denominator. So if I multiply this way, 4 times 4 is 16. And if I multiply this way, 2 times 8 is 16. Those two multiplications are equal. And that is a property of equal ratios. That will always happen. So if these two things are equal, that means that if I multiply this way, which gives me 18 times x, and I multiply this way, which gives me 27 times 6, those two things have to be equal. Now, going back to what you learned about solving equations, in order to get the x by itself, which is what we want, we're now going to have to divide both sides by 18. So if I divide both sides by 18, I end up with x equals 27 times 6 divided by 18, which is 9. And if you have a look at that, if we just go back to our last page, 27 times 6 divided by 18 is exactly the same thing we punched into the calculator earlier to get 9 for the isolation method. So it doesn't matter which way you do it, they're going to get the same answer all ways. And this is the one that I tend to like because you don't have to flip it over. If the variable is already on the top, isolation is pretty good, but cross multiplication works every single time if you remember how to do it. So give your homework problems a bit of a go.